Hello everyone, fantastic to be here and even better to see such an awesome and helpful audience. So thank you once again for this HDMI adapter. We wouldn't be here without it, right? Okay, so my name is Patrycja and today we are gonna explore privilege escalation in Kubernetes together. It's gonna include a lot of live hacking demos, so let's get ready for a ride. First, a brief introduction. I've been doing professional software development for over 25 years. So, yep, I do feel like a vintage dinosaur sometimes. But hey, who doesn't love a classic, right? I've always been close to code, and that bond still thrives today. However, over 2 years ago, I joined the dark side of platform engineering. And guess what? I absolutely loved it. Today, I'm a lead SRE engineer at Form3. What do we do at Form3? In 2 words, Form3 is a financial cloud. Basically, we provide payment as a platform model, allowing for easy integration with various payment schemes via REST API. We are a very technology-oriented company, fully remote, cloud-based with microservices architecture. Recently, we've been building this new payment platform based on Kubernetes and free clouds. So obviously, Kubernetes security is super important to us. What am I gonna talk about today? Just a splash of theory explaining Kubernetes architecture, privilege escalation, and Kubernetes threats. The key part of today's talk involves 4 demos where we are going to exploit various misconfiguration vulnerabilities in a Kubernetes application and Kubernetes cluster. Eventually, I will be able to hijack your accounts. We'll see. But before the fun part begins, let me brush on Kubernetes architecture, just for all of us to be on the same page and to understand better which parts of Kubernetes we could target during our attacks. So when it comes to Kubernetes, there is 2 main concepts here. Control plane and worker node. When it comes to control plane, we have like various components, API server, etcd, scheduler, etc. However, the heart of Kubernetes control plane is an API server. Basically, if you want to update or create or do anything with a cluster, you need to communicate with an API server and interact via tools like kubectl, right? Who knows kubectl? Yeah, everyone. So that's the key part. API server exposes this HTTP API. It's publicly available, not publicly, depends on configuration, but it's available to developers, and this way we can interact with the cluster. Another very, very important component is etcd. It's a key value store which basically stores the entire state of a cluster. So all information on all resources are available in etcd. This is important because once you get your hands on etcd, you have like full exposure on what's running and what's configured in your cluster, specifically secrets. On the other hand, you have worker nodes, and that's the place where the actual work happens. So the pods are running over there. And one important component to mention here is kubelet. Basically, kubelet runs on each worker node and is responsible for instantiation and execution of pods. Kubelet also exposes this HTTP-based API, similar like API server, but this API is for internal use only, so we shouldn't have access to it. However, sneak peek to our demos, we will exploit an unauthorized, unsecured kubelet API to get unauthorized access to our cluster. The title of the talk is Privilege Escalation. So what is it actually? A short definition. So basically, we deal with privilege escalation when an entity, user, an application, service gains more access or permissions than originally assigned. And we can talk about two forms of privilege escalation. One is vertical, so a lower privileged entity gains content access function assigned for higher privileged entities, so like coming from a regular user to a super admin in 10 seconds or something like that. And we can talk about horizontal privilege escalation, like a normal regular user entity service gains access to the content assigned for another regular user. What does it mean in the context of Kubernetes? So basically here we can talk about like accessing a cluster with extended permissions or interacting with a cluster as a different entity than originally assigned to us. We can talk about accessing different workloads, data inside our cluster. We can talk about escaping to node, like accessing node resources in various ways, like file system, networking, network interface, virtual network interfaces available on node, and any other resources. Another form of privilege escalation in Kubernetes could lead to accessing cloud resources. Usually our Kubernetes clusters are deployed into a cloud, and privilege escalation could lead to unauthorized access to the cloud resources. When we are talking about Kubernetes security, what kind of threats can we expect? There is not like one best threat model for Kubernetes. Kubernetes is still pretty young technology, and Kubernetes security is pretty complicated, and the resources are scattered in many places, and there is no like a single place when you can learn about everything. Saying that, let's take a look at this threat matrix for Kubernetes. Basically, it follows Mitre attack model. This is like de facto standard for threat modeling in the industry for many years. And in 2020, Microsoft published this threat matrix based on Mitre attack framework, which shows various risks and threats for Kubernetes. It was updated in 2021, and we do have privileged escalation column here. However, I don't fully like it. Why? Because it doesn't exhaust all possibilities privileged escalation in Kubernetes could be done. So basically, if we take a closer look at it, okay, access cloud resources, that's a very generic one. But we have like also different categories here, different abstraction levels. On one hand, we have very generic access cloud resources, and on the other hand, we have privileged container, which is like a low-level container configuration. Plus, for example, privileged container and host path mounts are not the only way to do privilege escalation in Kubernetes. There is like a bunch of configuration parameters that could be exploited to get to the node, to escape a container and escape to node. The same goes for cluster admin binding. That's only a single configuration. When it comes to security and access control, role-based access control configuration in Kubernetes, this is also a pretty complicated topic, and cluster admin is not the only way to do privilege escalation. And I will show you that later on. Another take on security risks for Kubernetes was done in 2022 by OWASP. OWASP is this very famous non-for-profit organization which aims at increasing security awareness among developers. And they publish those top 10 lists every couple of years for different technologies. And for the very first time in 2022, they published this list for Kubernetes. Here we don't have like directly privilege escalation. Why? Because privilege escalation is such a wide topic, and here there is more focus, like more technical risks, and those risks can be like combined together and used to exploit to eventually execute some privilege escalation in real Kubernetes clusters. When it comes to main paths of privilege escalations, we need to, when it comes to accessing cluster with extended permissions or different entities, it's all about compromised credentials, misconfigured RBAC permissions, secret management failures, broken authentication mechanisms, misconfigured cluster components, or outdated or vulnerable cluster components. So you see in how many ways we can access a cluster in an unauthorized way. So it only shows how many things can go wrong in our Kubernetes deployments. The same goes for other types of privilege escalations, like accessing different workloads or escaping to node. Accessing cloud resources is very similar to accessing cluster because it's all about getting access to some credentials which are stored in a cluster and then exploiting them. Okay, it's time for our demos. This is gonna be like 101 hacking course in Kubernetes, but hopefully I will show you how a series of simple misconfigurations can lead to a compromise of our entire cluster, or at least our demo application. So here I will need your help. I have this demo application, and it's available under devox.yonlabs.com. And I have a kind ask to you. Please go to this web application, register your accounts, and log in and wait to be hacked. My objective here is to hack your accounts and learn your secrets. You can scan the QR code. The link is also available on my Twitter account, /twitter.com/yonlabs. So please register. Obviously, don't use any real data, use nicknames, and don't reuse any real passwords because those could leak during our demos. I'm logged in. I do see some users already registered, so thank you for your cooperation. I already told that you are a very helpful audience, so thank you. So this is like a very simple application. Each user has its own profile with its own secret. So let's take a look at some security configurations here to learn more about this application. So basically, if we take a look at DevTools, we see that underneath this application uses JWT tokens as an authentication and authorization mechanism. So this is like pretty standard approach, but with JWT tokens, it's enough if a hacker gets his hands on one of the tokens, and basically they can freely use those tokens. So my objective here most likely will be to find or to grab one of your tokens, or we can take a look at how this token is defined. If we see the content of this token, we see that this token uses HS256 algorithm HMAC with SHA-256. So basically this means that this is like symmetric cryptography. With symmetric cryptography, it's enough to find the secret with which this token was generated. Once I know the secret, I can generate as many tokens as I can. So you more or less understand now what my attack vector gonna be. I'm gonna aim for your tokens, or I'm gonna aim for some secret which was used to generate the tokens. Okay, so that's it. Okay, I will log in to my evil server from which I will do all the hacking. And this is gonna be like the machine of a malicious employee, or perhaps hacked. We have access to hacked credentials, and basically we have access to kubectl credentials, but for Joe Doe user. So this user, it seems, doesn't have like very extended and excessive privileges. I can't do much. I can't even list namespaces. What can I do with this user? Let's take a look. So we can use this. Can I auth command with list parameter and see what can I do here? So basically you see that there is not much this user can do except impersonate. So what does it mean in this impersonate permission? Basically, this user can impersonate any other user or group inside a Kubernetes cluster. So instead of like getting namespaces as Joe Doe, I will try to get those namespaces as basically system masters user. System masters basically this gives us admin privileges. I messed up something, I guess. Let me try. Yeah, thank you. It's good that I prepared this cheat sheet because it's so easy to make a simple typo during live demos. Okay, so now we see like we can get all the namespaces. We do see like this very interesting backend namespace. So let's see what's running in this namespace. We see this demo server, so that's most likely our target application, right? Now what we can do, we can also display all the secrets in this namespace. We have some very mysterious demo secret, so let me get this secret displayed in a YAML. Thank you, you are very vigilant. And here is missing a. Definitely I'm not in my best form today. Okay, and so what do we see here? We see the secret key. What a surprise, right? If I didn't do that myself. So what can we do now? So that's most likely the secret used to generate our JWT tokens for authenticated users. Now let's go to this very handy jwt.io page, and I will just change a payload data. So instead, number one, it's me, Patrycja, user, and I will change this claim for Lucky 7, for example. I'm using this secret to generate signature, and it's enough for me just to go here and replace this secret with this generated one, and it didn't work. Let me try again. Perhaps I made some mistake, or let me use also another data, because if we don't have that user, I see, I haven't, I've copied the key in a wrong way. You see that there is like some leftovers from, yep. Yes, sorry for this one. Let's target now 3. And now it should be okay. Let's give it a try. And fingers crossed. Yes, Erwan, you've been hacked. Are you here, Erwan? Raise your hand. Oh, thank you. Oh, that's my pet payback for your adapter. Sorry for this. But at least perhaps you are having fun. Okay, so that was a very simple case of privilege elevation. We had this impersonate excessive permission configured for this user. Another permission we should be careful about is creation of role bindings, list or get secrets. And also create some executables like pod deployment, stateful set, etc. And also exec into pods. So those are pretty sensitive when it comes to privilege escalation, because in a wider context there is like more to think about. When you think about RBAC configuration and best practices, always follow the least privilege principle. I'm not sure if you ever had a cluster configured with time-based roles. That's very important and useful from the security point of view. So basically, a user is assigned a role which expires after some time, like 1 or 2 hours. So that's really useful if you deal with sensitive resources and sensitive clusters. And also, obviously, multi-factor authentication may come to the rescue in that case. Now it's time for our second demo. We will be escaping to Node. And again, I will use my evil cluster, but this time I will switch to John. And John also have pretty limited permissions. Let's see what permissions John has. And this time I will take a shortcut. Instead of some reconnaissance, I know that this user has something to do with this full app namespace. And it turns out that this user can basically do everything with pods and deployments, and even can exec into a pod in this particular namespace. So basically, this user is kind of an admin of full app application. So what can we do here now? We can deploy a new pod. And this pod basically will have all the extra security permissions assigned. So basically it's a host network, host PID, host IPC, volumes mounted, privileged mode, and running as user root because we don't have any user assigned. Also, if possible, we will schedule this on a control plane. How to find out the control plane? It's configured in the permissions. I just inferred the node name based on some information like from kubeconfig together with information that this is running in an AWS. So basically, I will just apply this one. And I will try to exec into this pod. and I will be just executing bash. So I'm inside this pod, and basically if it's mounted, if it's deployed in a privilege mode with all those extra permissions configured, it's like I'm on the host. The only thing is that that I have this host volume mounted on the host path. So if you see host here, that's like accessing the underlying file system. So the only thing I need to change is change root for host. And basically I can do, this is like a full compromise of an underlying node. I can do anything what's allowed on the node, but I'm targeting like this demo applications. I want to learn your secrets. So basically I'm trying to get again to this JWT secret. The regular way to do this, like kind of reconnaissance, is usually to search for kubeconfig configuration here. So I will search, and we know I need this one now because this is like my root now. I do have some configuration already found. Let me see this one. I need this one to be displayed. And surprise, surprise, we found Kubernetes admin here. So basically this is like leftover. Let's try to use it. Oh, actually, I don't remember the path now, but thank you. Oh, thanks me for this cheat sheet. That's super helpful, especially as I'm doing those demos for the first time live. So yeah. I must say that's pretty challenging. Let's try nodes. Okay, we are here. And again, get secrets. We know now a little bit about our application. So again, the same way, the more secret, and we want this output in YAML. And yeah, we've got the same secret. So let's give it a try once again, but this time for this lucky or unlucky for me 7. Who was that, or who is that? Total Hariko, sorry, I'm not able to pronounce it. I hope this is nothing offensive, is it? Oh, that's good. And who is that? Are you here? Thank you and congratulations. You've been hacked. And you caused me a lot of troubles during the first demo. Another way to look for the secrets is like to look at etcd, right? So once we are on this on this node, let's see the process of etcd, and here we see very important configuration. This one. Data dir. So basically etcd is key value store, and it stores the configuration in some files, so we can basically access them. If we want to access them in like more human-friendly form, I need only this var lib one. Okay, let's do that. and that's our DB. Oops, yeah, definitely too much. Yeah, okay, and you see that I don't need like super complicated tools to do this hacking, and I want to see this demo secret once again if I haven't seen it twice so far. Yep, it's here, it's the same, and you see that with the direct access to etcd, we have access to everything, all the secrets available in the cluster. Let me try it once again, just for more users to have fun. Let's try unlucky 13. And this time it's gonna be like, oh, dog. Are you here, dog? Perhaps some online attendee as well. Okay, so you've been hacked several times so far. Here I have a very good resource for you. When it comes to node escape and Kubernetes pod privilege escalation, there is that excellent blog post by Seth Ard, together with this GitHub repository, and it explains the danger and impact of various security configuration in Kubernetes deployments or executable. The problems in our demos, which we could observe, is like insecure workload configuration. So basically, we went like full on with root, privilege, host PID, host path, host network, and host IPC. That's in real world, that's like a big no. So be careful about those parameters. Another thing is lack of centralized policy enforcement. Obviously, such misconfigured workload should be denied access to our clusters. So we need some sort of admission controller to control what can be deployed and what can run inside our clusters. And another issue is secret management failure. Our demo secret was not encrypted, and that's a feature, not a bug in Kubernetes. Secrets are not encrypted, so if you want encrypted and sensitive resources, do it yourself, right? Configure that on your own. So unfortunately, Kubernetes won't do that for us. With our third demo, again, I will show you escape to node, but in a slightly different manner. This time I will switch to, sorry, I'm in this, I'm getting back to my evil server, switching to Jane user. Again, this user doesn't have much privileges, however, she is an admin for bar app, and she can create deployments in bar app namespace. However, she can't like execute into a pod. So, so what can we do now? First of all, we are not going full on with this one. We are only like using privileged mode and host PID plus root user, and And to bypass the lack of pod exec permission, we are doing a reverse shell. So basically, what is a reverse shell? Under like normal circumstances, when you want to access a remote machine, you are doing like SSH, and you are providing your credentials, and you are given a shell. Reverse shell is the other way around. So instead of client machine connecting to a remote server, the remote server connects to a client machine, this way bypassing this credential step, or in our case, bypassing the lack of pod exec permission. For this one, I will need like another session because if the remote machine is supposed to connect to my evil server, I need to open some process to listen on this machine. I need to log in to my evil server, and I'm just simply opening this process, and I will just apply this this manifest. Okay, looks fine. Deployment created and connection received, right? And we have a shell. That's a shell inside our target pod. So the pod we created, but we couldn't exec into. What can we do now? We can list all the processes, and as this is like host PID parameter enabled in our deployment, it means that we have access to the underlying host PID namespace. To compromise a node, this time we need to target this init process. And we can do this via ns-enter command. This is like namespace enter. We want to enter the namespace of our init process. However, first, to show you that we are on the pod, I will display uname. You see that we are inside the pod. So now I want to escape to our node. So I'm entering the namespace of this process one init process namespaces. And now let's see what happened here. I'm still, I need to enter all target one, all and bash. And you name, I'm messing something. Let me take a look at my cheat sheet. That's one like drawback of this reverse shell. This reverse shell is not like fully interactive shell, so I don't see the error messages. If I want to see the error messages, I need to redirect error message stream to the regular standard output stream, and that's why I didn't notice that that I had a problem with this command. Let's execute bash inside a namespace of this init process, all namespaces of the init process. And now we are inside inside our node. And what can we exploit here now? Basically, I told you about virtual CNIs and virtual network interfaces. Basically, each CNI usually works the way that it creates those virtual interfaces and injects like custom IP tables or eBPF rules to allow for this pod-to-pod communication. Because with Kubernetes, there is this overlay network coming that allows for all pods to communicate with all other pods by default. So basically on the node level, it means that we will have like a bunch of virtual interfaces. You see them here. Now I will just run TCP dump to sniff on those interfaces, and I will ask you to refresh the pages in our demo app. I want to find some tokens. Thank you. A lot of traffic coming in. Oh, too many of you. I need to stop it. Yeah, I need to stop it because you already seen what I'm looking for. I'm looking for the headers from HTTP requests because those headers include this authorization bearer tokens, and I can grab one of those tokens, and instead of generating new tokens using secrets, I will basically I'm just stealing one of your tokens. And who was that? That's Sam. Are you here, Sam? I don't see you, but you've been hacked. Thank you for your cooperation. So that was our third demo. And you've seen that even with like more limited privileges, but still some pretty misconfigured workload, we could escape to node. Basically, you have like the analysis of all the parameters in this blog post. I highly recommend this one. Most of those privileges or most of those configuration parameters can lead to a full cluster compromise. However, not always in a very simple way. Sometimes it's like more complicated. But even if nothing's allowed, it doesn't mean that your cluster is safe. So don't feel so safe. I had one more demo, but I won't have time to show you that. Maybe next time. So just some final words and summary. I can tell you that's only the tip of the iceberg when it comes to Kubernetes security. So that's like huge, wide topic. I could go on and on, but we are running out of time. It's worthwhile to remember the Swiss cheese security model. Why? Because that's like a fundamental paradigm when it comes to security. The security in depth principle with many layers of security defensives. It means that one layer can cover the holes in another layer. So it's important to design your systems in a way that you have multiple security mechanisms stacked upon each other. But remember also that it's not about perfect security. That's impossible. It's all about like making life harder for bad guys while making it easier for us good guys to detect any potential threats faster and in an easy way. Remember that a fool with a tool is only a fool. So we DevOps developers, engineers, we need to know and use our tools wisely. This is this fundamental paradigm. We talk in software development world, we talk about continuous deployment, continuous integration, but the fundamental paradigm is continuous learning. It's all about learning and educating ourselves. So let's keep learning. And basically that's what the conferences are all about, right? About learning. So thank you for today's learning and thank you for such an effective cooperation.